Hi guys, today we are going to learn about average atomic mass and relative atomic mass. At the end of this video, you are going to be able to calculate the average atomic mass of an element given the relative abundances of isotopes or a mass spectrum. Next, you will be able to calculate the relative atomic mass based on carbon-12 scale. Most of the elements have isotopes. Therefore, the atomic mass of an element represents the average atomic mass of isotopes. An element's atomic mass is the weighted average of the isotopic masses of the element's naturally occurring isotopes. For example, the atomic mass of hydrogen atom is 1.01 AMU. Carbon atom is 12.01 AMU and magnesium atom is 24.31 AMU. All of this data can be obtained from the periodic table of the elements. As you can see, the atomic mass of magnesium atom is 24.31 AMU. But do you know how do scientists determine the atomic mass of any element? Let's learn how atomic mass of carbon is being calculated. Carbon has three isotopes, which are carbon-12, carbon-13, and carbon-14. Carbon-12 and carbon-13 are stable, while carbon-14 is a radioactive, so it slowly decays. On Earth, there is a lot of carbon-12, little bit of carbon-13 and a very small amount of carbon-14. Since the natural abundance of carbon-14 is so small, therefore it can be ignored. Thus, atomic mass of carbon appear on the periodic table of elements is being determined only by using carbon-12 and carbon-13 percentage abundances into the calculation. Carbon-12 has isotopic mass of 12.0000 AMU and its percentage abundance that naturally found on Earth is 98.9%, while carbon-13 has the isotopic mass of 13.0034 AMU with its percentage abundance only 1.10%. So, how are we going to use this data to determine the atomic mass of carbon? Since there are two major isotopes of carbon, firstly, the average atomic mass of this element must be determined. The percentage abundance of carbon-12 is multiplied with its isotopic mass plus the percentage abundance of carbon-13 multiplied with its isotopic mass. From the calculation, the average atomic mass is 12.0110 AMU. Average atomic mass is expressed in atomic mass unit, AMU. Remember, most of the carbon on Earth is carbon-12, so the average atomic mass of carbon should be really close to the atomic mass of carbon-12. Most elements occur naturally as a mixture of different isotopes. The average atomic mass of element is numerically same with the atomic mass. Thus, if you look at the periodic table, you'll see listed below the symbol for each element a values called the element's atomic mass. The most direct and accurate method for determining atomic mass of an element is with an instrument called a mass spectrometer. The mass spectrum that results is plotted as a graph of percentage abundance or relative abundance against isotopic masses. The abundance of each isotope is shown as peaks in the mass spectrum obtained from a mass spectrometer. Number of peaks indicate number of isotopes. The higher the peak, the more abundant is the isotope. Let's look at this example. Chlorine has two isotopes, which are chlorine 35 and chlorine 37. Their isotopic masses are 34.9688 AMU and 36.9659 AMU respectively. What is the average atomic mass of chlorine? From the mass spectrum, we can see that chlorine 35 has a higher peak. It shows that it is the most abundant of chlorine isotope. The percentage abundance of chlorine 35 is multiplied with its isotopic mass plus the percentage abundance of chlorine 37 multiplied with its isotopic mass. The average atomic mass of chlorine calculated is 35.4525 AMU. On the periodic table, you'll see listed below the symbol of chlorine is 35.45, which is the chlorine's atomic mass. The atomic masses listed in the periodic table is not always a whole number because atomic masses are weighted averages of occurring isotopes. Relative atomic mass is defined as the mass of one atom of an element compared to 1/12 the mass of one atom of carbon-12. Hydrogen is the lightest atom. The atomic mass of hydrogen is 1.008 AMU. It has 1/12 the mass of one carbon-12 atom. So, its relative atomic mass is 1.008. Magnesium atom is twice as heavy as carbon-12 atom. Thus, its relative atomic mass is 24.31. Relative atomic mass tells us the mass of one atom compared to one carbon-12 atom. In other words, relative atomic mass tells us how heavy atoms are compared with the mass of one carbon-12 atom. For example, neon has 3 isotopes. From this data, how the relative atomic mass of neon is being calculated? Since neon have 3 isotopes, its average atomic mass must be determined. In the first step, multiply the percentage abundances of neon with its isotopic masses. From the calculation, the average atomic mass of neon is 20.1800 AMU. Next, to determine the relative atomic mass of neon, the mass of one neon atom must be compared relatively with 1/12 of the mass of one carbon-12 atom. The mass of one carbon-12 atom is 12.0000 AMU. So, the relative atomic mass of neon is 20.1800. Relative atomic mass is a dimensionless quantity. Therefore, it has no units. Next, to determine the relative atomic mass of neon, the mass of one neon atom must be compared with. Next, to determine the relative atomic mass of neon, the mass of one neon atom must be compared relatively with 1/12 of the mass of one carbon-12 atom. The mass of one carbon-12 atom is 12.0000 AMU. So, The relative atomic mass of neon is 20.1800. Relative atomic mass is dimensionless quantity. Therefore, it has no units. Let's try this question. The answer will appear in 15 seconds. Thank you for your attention and see you in the next video.